Good morning, grade 12s, and welcome to this morning's mathematics webinar. As you are accustomed to, I always allow for 2 minutes just for attendees to still sign in and join us for today's session. So I will see you in approximately 2 minutes' time. Right, so if I didn't greet you this morning, welcome to this morning's webinar, and I hope that you will learn a lot from today. Before we start, I would like to cover some basics so that you know what is expected of you and how the session will work. For those who don't know me yet, I am Linky Young, the Chief Education Specialist at Impact for Mathematics and Sciences. Right, so if you're struggling to hear me, please make sure that your audio is on and that your speaker volume is turned up. I'm just going to highlight that for the guys that can't hear me. Please make sure that the volume is turned up quite high, as we realize that sometimes when that is not up to the maximum volume, you struggle to hear us as well. So just make sure that you can hear me nice and clearly. You will automatically be muted when you join into this session. Now, I do allow times where you can ask your questions and provide some comments if you'd like. And in that times, I will unmute you. You can ask your question and I will mute you afterwards as well. I will guide you during this webinar when we do that. But should you have any questions, please keep this for when I ask you if you have any questions, or when I ask you if you can still hear me, to just indicate that. But you can use the raise your hand icon. You will see that there is a little hand on your dashboard, and you can quickly test it out, put up your hand, see how it works. You can even take it down on your side if you don't have a question anymore. Yes, there we go. I see there's only 2 that is playing around with the hand icon. So check for your hand icon and please press on it so that you can put up your hand so that I can see that you can hear me. There we go. That's better. All right, so I am just for now going to take down the hands. You can download this presentation in PDF format in the handout box. So on your dashboard, you will see that there's a handout box, and in there you will find the PDF version of this webinar. So the slides of this, you're welcome to download that and keep it for notes that you can use later on. Please do that during this webinar, as when we stop the broadcast, it won't be available for download on this platform anymore. You will, however, be able to download it on the guided learning platform under resources. You will also find all of this information in the question box on your right-hand side or at the bottom of the screen. That is also on your dashboard. You are encouraged to ask questions or leave comments. However, should you leave irrelevant or inappropriate comments or questions, you will be dismissed from this session. If I do not get to your academic question today, which usually doesn't happen, you're welcome to send an email to academics@impact.co.za. You can also ask your questions in the question box if you are not comfortable with asking it live on here. There's someone who would like to join into the presentation, as you can hear. Right, so if I do not get to your question in the question box, and Okay, so if I don't get to the questions, I will provide you feedback via email. If you did not receive it and you still have an unanswered question, you're welcome to send an email to info@impact.co.za. Right, so Impact has a YouTube channel now, and all of the recorded webinars is available there for you to view. And I will share this link for the YouTube channel at the end of this webinar. Right, so we went through all of that. Quickly just put up your hand, show me that you're ready and that you can hear me before we move on. Great, it seems like everyone's audio is sorted. And most of you, there's a lot of hands going up, so it seems like you know where your hand icon is as well. Right, so for now, I'm going to take down the hands again before we move on. So I just quickly want to give an overview on term 2 topics and talk about what we did discuss already, and so that you also know what you can work on your own, on your side. So firstly up is calculus, which is a continuation of term 1's work, number patterns, and analytical geometry, and a bit of statistics revision. Now, we did do analytical geometry in our first few webinars as well, and the notes. So the recordings of the webinars you can go and download on the YouTube channel or look at it on the YouTube channel. And the notes that was sent out during that time is available on the guided learning platform under resources. For today, we will continue with number patterns. Now, if you've downloaded last week's notes from the guided learning platform, you will see that we started with number patterns, which is your arithmetic patterns and your geometric patterns. There's 2 more that we need to do, which we will look at today. Number patterns, it also has a number name which we call sequences and series, and this is the more common one that you will find in textbooks. They usually refer to sequences and series. So if you do a bit of research on the internet and want to look at lessons or videos or some extra notes, if you come across the words sequences and series, it also refers to number patterns, what you are busy with at the moment. Number patterns you can expect in paper 1. Let's look at the different topics or the work that you will have to cover in number patterns. So you need to find the general term and solve problems relating to arithmetic sequences, geometric sequences, and quadratic sequences. Secondly, you will need to find the sum of n terms and solve problems relating to arithmetic series, geometric series, and infinite geometric series. Right, so in our previous webinar, we talked about the difference between sequences and series, where a sequence is just the number pattern given to you. A series is where I add those terms together. So it's an addition of terms, the sum of terms. Then we call it a series. So those that is indicated at the moment were done in the previous webinar, as well as in the notes that was sent out last week. So arithmetic sequences and series we did in the previous webinar, and in the notes was the geometric sequences and geometric series. For today, we will then look at the quadratic sequence and the infinite geometric series. Luckily in grade 12, as I mentioned, you will be provided with a formula sheet. And all of the formulas that you will need with sequences and series, you can find on this formula sheet. And I've indicated for you where you can find it on this formula page. We also looked at what each of these formulas stand for and what you can calculate with it. So just want to get this right. So this equation over here, this formula over here, can be used with your arithmetic sequences, where we looked at the different variables over here. So your Tn is indicated for the general term. A is the first term of the sequence. N is just the number of terms, and D is my common difference. The general term for a geometric sequence was discussed in the notes that was sent out. So Tn still represents your general term, A, your first term of the sequence, and your R is your common ratio. So there you will divide between terms to find your common ratio, and your N is your number of terms. Right, then in our previous webinar, we also looked at the arithmetic series, and we've also identified and defined the different symbols over there and in the notes on the geometric series. We said that series refers to the adding of terms in a sequence. So when I add the different terms in my number pattern together, we refer to it as a series. Okay, so today we're going to focus on this purple equation over here, the infinite geometric series. And then if you note, there is no mention of a quadratic sequence over here. And this is because it is not given on the formula sheet. It's quite an easy equation to remember, and that is why it is not included in the formula sheet for you. Okay, so let's move on to that. I want us to start to look at a quadratic sequence. And they have provided the formula for you. So Tn still represents your general term. That's what you're going to use to calculate it. It's equal to an squared plus bn plus c. So a, b, c is your variables in front, and then you have n in decreasing in an squared plus bn and then plus c, your constant term over there. Right, so I'm just mentioning it again. This will not be on your formula sheet. Like I said, still stands and represents your general term. And this is kind of usually what they ask you when you need to calculate general or when you work with quadratic sequences. So they will ask you the general term and then a specific number of the terms. And I'm going to use an example to explain this to you. So the question is, find the general term and hence the number of terms in the sequence of 5, 10, 17, 26, and 10,202. I've mentioned this in the first webinar, and I want to mention it again. They will not tell you, you are now working with a quadratic sequence, or this is a geometric sequence. Or an arithmetic sequence. Now, you will have to investigate what type of sequence is given to you. So this is the 3 steps that you're going to follow. You will firstly test if this is an arithmetic sequence. And how do I do that? One of the characteristics of an arithmetic sequence is that I have a common difference. So we said that you will take your second term minus your first term, and your third term minus your second term. And if that difference is the same, I have a common difference between the terms. And that is when I know I'm working with an arithmetic sequence. So if I look at this sequence given here to me, if I say 10 minus 5, it will give me a difference of 5. 17 minus 10 is 7. So definitely these two differences is not the same. So I can delete and scrap out arithmetic sequences. So this is not an arithmetic sequence. The second step is then to check, is this a geometric sequence? So with geometric sequences, you will divide the consecutive terms with each other. So you will say 10 divide with 5, that's 2. 17 divided by 10 is 1.7. So my ratio is also not constant. So this is also not a geometric sequence. So to determine the third step that you're going to use to determine what type of sequence you have, you are going to do a difference, but you're going to do it twice. And a quadratic sequence has a common second difference. And I'm going to show you how we're going to calculate that now. So I just want to recap. You only have three types of sequences: arithmetic, geometric, and quadratic sequences. With an arithmetic sequence, you will have a common first difference. With a geometric sequence, you will have a common ratio between the terms. And thirdly, you have a quadratic sequence where you have a second common difference. Right, so let's see if this is a quadratic sequence. So I'm going to take the sequence that they've given to me, and I've just made it a bit bigger to show you, and I am going to calculate the difference between consecutive terms. So 10 minus 5 is 5, 17 minus 10 is 7, 26 minus 17, 9, and it can carry on. But you can already see that this is definitely not a common difference, so I eliminate arithmetic sequences. Right, so if I now say 7 minus 5, I get an answer of 2. 9 minus 7, I get an answer of 2. Do you see that the second time that I calculate the difference, I have a common difference? So a quadratic sequence is indicated by a common second difference. Right, so as you see there, we have a common second difference, and that tells us that we are working with a quadratic sequence. So these three equations that I'm going to show you now will also not be given to you. It's quite easy to remember, and that is actually the steps that you're going to use to calculate your general term, that Tn is equal to an squared plus bn plus c. So there's three variables, a, b, c, and I'm going to use these three equations to calculate a, b, c. Right. The first one is 2a is equal to the first term of the second difference. So there is the first term of the second difference. So 2a is equal to 2. The second equation that you will have to remember is 3a plus b, and that is equal to the first term of the first difference, which in this case is a 5. You will say 3a plus b is equal to 5. The third and last equation that you will have to remember in this calculation is a plus b plus c, and that is equal to the first term of the sequence. In this case, again, it is a 5. So you'll say a plus b plus c is equal to 5. Now let's see how we are going to calculate these variables a, b, and c, as I needed to write the general term, and the question asks to find the general term. So let's look at this first one. I said that 2a is equal to the first term of the second difference, in this case, a 2. So you will write 2a is equal to 2. You can divide both sides with a 2 and get to the conclusion that a is equal to 1. So now I have one of my variables in that equation. I'm going to move on to the second equation over here. So I'll say 3a plus b is equal to the first term in the first difference, which is 5. 3a plus b is equal to 5. But I do have the value of a already, and I can substitute it in there. I've calculated it in my previous step. So 3 times 1 plus b is equal to 5. And you can calculate then that b is equal to 2. Now I have the variable a and I have the variable b. I'm going to move on to my third and final equation to use and say a plus b plus c is equal to the first term of the sequence, which is 5 in this case. I do have a value for a. I already have a value for b, so I can substitute it in there. And then c is my only variable left to calculate. When you calculate c, you will get to c is equal to 2. Now, like I said, in your general term, we made mention of a, b, and c. And you have values for that now. So in the place of a, b, and c, you can substitute these values. Now, in this case, A will be 1. You don't have to write a 1 because 1 times anything is that anything. B is 2 and C is 2. So that equation that you see over there is the general term for the quadratic sequence that is given over here. So we did calculate the general term, but there's a second part to this question. It says that you need to calculate the number of terms in the sequence. And I see that the sequence carries on until it reaches 10,202. Now, the number of terms, if you look at our previous notes and webinars, you know that it is represented by an n. I need to calculate n. And I know that I can use this equation that we just did because this is the sequence that is given to me. So you will use n squared plus 2n plus 2. And you're going to calculate n. Now I know that there's a total, or the sequence, the final sequence is 10,202, the number, that term in the sequence. And I can substitute it into Tn is equal to n squared plus 2n plus 2, and you are going to solve n now. If you struggle with this step, I want you to go back to term 1 and revise your algebra, because this is just factorization and then solving a quadratic equation. Right, so I've taken that over, factorizing over there, and I get that my number of terms is 100 or negative 102. Now, in these cases, and especially with number patterns, they will give you stuff like this in the quadratic sequence, where you have a negative number of terms and a positive number of terms. You cannot have a negative number of terms. It's as good as I tell you, please give me negative 200 sweets. How do you do that? You can't count a number of terms that does not exist. So you cannot have negative number of terms. You can only have a positive number of terms. This indicates that this negative 102 is not applicable. So it means that there are 100 terms in this specific sequence. Right, so there's a few steps that you need to do. You need to remember the general term. Tn is equal to an squared plus bn plus c. And now you need to calculate the variables a, b, and c by remembering these three equations over here. Just to substitute in there. Right. Is there any questions regarding this quadratic sequences? You can put up your hand and I can assist you with your question. Seems that everyone is fine at this moment. I am just going to check over here, and it seems like there's no questions here as well. Okay. Right, so that's great that everyone is on the same page and you know what's going on. So I'm going to move on, where we're going to have a look at infinite geometric series. So this fits into your geometric sequences and series calculations. And if you look at the notes, you did calculate the sum of a geometric sequence, which we call the geometric series. But now we talk about an infinite geometric series. So if you talk about infinity, you can't put an end to infinity. So it means that it's actually a geometric sequence that never ends that you're going to work with. Now, I've said that you're going to use this equation, and it is also provided on the formula sheet for you. So it's easy to recognize because it has that infinity sign next to the sum. So the sum of infinity is equal to a over 1 minus r. Your a still represents the first term of the sequence. Your r still represents the ratio. Now you will see that they've given there, just after the semicolon, a restriction. It says that r should be between -1 and 1 for you to be able to make use of this equation. So there's a very specific restriction given to you, We will talk about what it means as well. So if you need to define a geometric series, you will say an infinite geometric series is the sum of an infinite geometric sequence. This series would have no last term. So you won't know where it will end. That is when you will make use of this to infinity. So we talked about this restriction, and it has to do with the algebra behind it. So as you know, we are not allowed to divide with a 0. Then it will give us an undefined answer. It is an error if you do that on your calculator. Therefore, this relationship signs over here is not inclusive of -1 or +1 because it will result in a 0 in your denominator. This also has a specific meaning for the type of series. It is a convergent series. It means that it nears something, but it never touches. Right, so you will see that you will get to very specific answers in your questions with this. So firstly, you need to make sure that your ratio is within that restriction that is given. And they also kind of ask you things like, is this a converging series? And then you just calculate your R. If the R, your ratio is between -1 and 1, you know that your series are converging. So the example says, find the sum of 1 plus 0,5 plus 0,25 plus 0.1.5. Okay, and it carries on. I do not see where it ends. It has no last term. And that indicates to me that I'm working with an infinite geometric series. That makes me know that I can use the sum of infinity is equal to a over 1 minus r. But there's still one thing that I need to check. Can I use this equation? And how do I know that? I need to test if my ratio falls into the restriction. I'm going to calculate my ratio, and my ratio says the second term divided by my first term, or my third term divided by my second term, and so on and so forth. So if you do that, you will see that your R is equal to 0.5. So I've just taken term 2 divided by term 1, and that gives me 0.5. Now, if I look at my restriction, 0.5 falls in that restriction, and that means that I am allowed to use the sum of infinity is equal to a over 1 minus r. So I'm going to take this equation. I'm going to substitute my a value, which is the first term, 1 minus my r that is given. And you will get that the sum to infinity of this specific series is equal to 2. I want us to look at another way of writing this. Now, if you think back to last week's notes, you will see, I don't want the highlighter to show you, there you go, that a geometric sequence, the general term of a geometric sequence is given by I times r to the power n minus 1. If I look over here, a times r to the power n minus 1. And so we sorted with this side of the equation, but what does this mean? This is a summation sign, and summation means the sum of, adding together. And how many terms do I need to add together? I need to add it from the first term, because it says n is equal to 1, from the first term up to infinity. That indicates that I can use the sum of infinity. Right, so before we carry on, you actually have two choices on how you want to get the variables to add in here. So you want to get the value for a, and you want to get the value for r. So you can substitute your n is equal to 1 in there, and you will get that your first term, which is indicated by A, is equal to -6. And you can calculate your second term by substituting a 2 into the n, and so on and so forth. So you can calculate a number of terms and then divide them with each other to get the r. Luckily, in this case, if you look at the general term of a geometric sequence, a times r to the power n minus 1 is what is represented here. A times r to the power n minus 1. So I don't have to calculate anything to substitute into my sum to infinity equation. You can just take it from what is given over here. Your a will be -6. Your r will be -1/2. Okay. And there I've just defined that for you. We know that we are allowed to use this because -1/2 falls into the restriction of my ratio that is given. I can substitute my values in there, and you can do that on your calculator. You are allowed to use your calculator, as it does not stipulate that you are not allowed to use your calculator, and you will get an answer of -4. So these two things that we discussed today is not very difficult. It's easy to interpret. You just know where to find what of the variables that is actually given to you. Remember, with the quadratic sequences, that you need to remember the equation by itself. It's not provided to you, as well as those three to find the variables A, B, and C. So, do you have any questions regarding today's webinar that I can assist you with? You're welcome to put up your hand if you have any questions. Kevin, thank you so much for your nice compliment over here, and I'm glad you enjoyed it for today. I don't see any hands going up. I'm so glad that all of you understand this and that you are on track with this work. It was a pleasure for presenting this today to you guys. I enjoyed it a lot. I just want to add this extra work that you can go and visit. Go and look at the links. There are some videos explaining the work, or there's some extra practice that you can do online, and just get that skills very settled in at the moment. So you can go and visit those links that I've provided over there for you. And then I've also provided YouTube links to Unpack created videos where there's also explanations regarding what we discussed today. And then at the bottom, you will see that there's a link of the YouTube channel. And as I said, you can find all of the pre-record or the previous recorded webinars that we have done. Today's webinar will also be available later today or by next week. You can find that on that channel, and remember to visit the guided learning platform for previous notes and for the PDF versions of this paper. I see that there's a question that came in the box. I just know where. Is there anywhere we can get the questions and answers from the webinars asked? So Janice, the best will be that you go back to the recordings and just listen to the question that was asked. Like I said, we only provide email feedback if I did not get to all of the questions. Yeah, so she says that the audio might get lost and they miss us because of the connectivity, and that is why we make the recordings available. So please go when you have the time next week, just go and look at the videos again, download it for yourself, work through the questions should you have any questions, or you ask questions and you want to go back to that. All right. Thank you so much, grade 12s. I enjoyed today. there. So if you are not registered with Impact and you have some questions that you would like to ask and you would like to find out more about Impact, please contact us at info@impact.co.za. Thank you so much for joining me today and the nice compliments that I see coming in. It was a pleasure to be with you today. Please be safe, keep healthy, and enjoy the times with your family. See you next time. Bye-bye.